Like a Spanish galleon moored offshore, frozen in time for all to adore. Though a ship in the desert might seem out of place, an ancient sea once gave this landscape a different face. This is where our story begins. Indeed, 340 million years ago, Sedona would have been submerged beneath a deep tropical sea. After about 20 million years, this ancient sea retreated. A coastal plain now predominated, but the sea continued to rise and retreat over the plain for about 30 million years, depositing alternating bands of sedimentary rock. Sandstone from the sand dunes, mudstone from tidal areas, conglomerate from river floods, and limestone from the deeper sea. Altogether, this sedimentary layer is known as the Supergroup. Supai rock is seen here in the foreground in Oak Creek Canyon, with Cathedral Rock in the distant background. About 285 million years ago, the ancestral Rocky Mountains uplifted in southwestern Colorado. These mountains have long since eroded away, but the rivers once flowed southwest towards Sedona. When these rivers flooded their banks, they left behind sediment that over time would become the Hermit Formation. This layer erodes relatively easily and is thus a layer upon which most of Sedona's forest grows and upon which most of Sedona is developed. The landscape would change again. This time sand dunes began to cover the area, flanked by the ancient Pedregosa Sea. Periodically, the sea encroached upon the dunes, leaving behind sandstone known today as the Schnebly Hill Formation. This formation constitutes most of Sedona's famous landmarks, such as the famous monuments pictured here. There are actually 4 layers or members within the Schnebly Hill Formation. Of particular interest, the Fort Apache limestone member is readily detectable as a 10-foot thick layer sometimes likened to a bathtub ring shown here in the chapel area. This member marks a period of time when the Pedregosa Sea consistently submerged Sedona. This important erosion-resistant rock forms, for example, the capstone of Bell Rock, the saddle at Cathedral Rock, and the ring at Merry-Go-Round Rock. Eventually, the sea vacated the area, leaving inland sand dunes to cover the terrain. With no water to rework the dunes, wind remained as the dominant force to work the land. The result of these factors was a new sandstone layer made of larger individual clasts than the lower layers worked by water. This larger clast size allows iron to leach out of this layer as water passes through its relatively porous constitution. For this reason, Coconino sandstone is much paler than the layers beneath it, which, due to their smaller clast size, trap the iron. The iron oxidizes, forming the rust colors for which Sedona is so famous. Sandstone that has been worked by wind rather than water also develops an angled or cross-bedding profile, such as the Coconino sandstone pictured here. The sand dunes predominated the area for about 3 million years before a shallow sea approached from the west. The area's climate at this time was very hot. As groundwater seeped beneath the land and eventually rose to the surface, it carried with it salt and minerals. Upon reaching the surface, the water quickly evaporated, leaving the salt and minerals behind. This precipitate accumulated over a few million years to varying thicknesses around the area. This shallow sea would rise yet again to submerge the area. This deeper sea was rich in marine life and deposited yet another layer of sedimentary rock known as the Kaibab Formation. And so the many layers of Sedona were laid in place. At this point in time, about 270 million years ago, the area would have appeared quite unremarkable. Eons of history entombed in layers beneath the relatively flat surface of its uppermost layer. As if the clay had slowly and painstakingly been prepared, the sculptor, patiently waiting his cue, was finally ready. With no less than tectonic tools at his disposal, he would now go to work. During the ensuing Mesozoic era, dinosaurs roamed this area. This was also an era during which Pangaea, the supercontinent, split and the resulting continents slowly migrated in all directions. Toward the end of this era, the drifting North American continent collided with another piece of the Earth's crust in the Pacific. This resulted in massive compressive forces that uplifted the Colorado Plateau. The southwestern edge, known as the Mogollon Highlands, uplifted highest as the plateau sloped downhill to the northeast towards Sedona. Subsequent downfaulting and erosion displaced the highlands and a large portion of the plateau, bringing it closer to its current profile. About 15 million years ago, in the current location of the village of Oak Creek, a volcano began to spew lava from the southwest rim of the plateau, accumulating erosion-resistant basalt rock. In the millions of years since, the plateau has eroded back about 4 miles to its current location. As it retreated, some areas eroded more easily than others due to the constitution of the rock layers. This differential erosion has left behind Sedona's famous red rock formations. The tectonic forces that created the massive uplift of the plateau also created a fault that would begin carving Oak Creek Canyon. Eventually, the compressive forces responsible for lifting the landscape released. In some areas, such as the Verde Valley, this created downfaulting. Over 8 million years, this low-lying area filled periodically with lake water, while the Oak Creek Fault ushered in volcanic activity. As the lake waters dried up, they left behind Verde Formation as thick as 3,000 feet in the Central Valley. This sediment is readily visible at Montezuma's Castle, shown here. Snowmelt from Flagstaff's San Francisco peaks fed springs that flowed through the canyon. The loose basalt from the lava flows assisted in grinding of the canyon to its current depth in a matter of about 2 to 3 million years. And so it is that this timeless yet ever-changing landscape reveals itself in its most current form, a geological tome many chapters thick and many more waiting to be written. Sure, it might just be a simple happenstance, a scientific result of differential erosion and chance, that sculpted this skyline with such architectural flair and threw down bold color as if on a dare. But isn't it more exhilarating to sense a childlike artist at play, experimenting with color, form, and lighting day after day? What would it be like to create on a scale so grand? What would you make if you were the sculptor of this glorious land?